Hey y'all, welcome back. Today I'm going to be looking over this worksheet with you. I'm going to do the setup for each one and then a few examples working through this. One thing I do want to note is when we're doing these, you are not expected to do the full proof like they're doing. Each one should have you need 4 steps for me. You need to tell me which 3 things you're using and then which of the congruencies you're going to need. So for example, if you're going to give me ASA, you need to tell me here's my angle, here's my side pair, here's my angle pair, and then therefore these are the ones that match. And so I'm using angle, side, angle. So basically you're saying which of these 4 that we have so far am I using, and then how do I know those 3 things are matching. So I'm going to try and model that a little bit better here. We don't need, wait, what did I do? That's not the thing I wanted to white out. That's the thing, I already did this on your papers, but I forgot to do it on my example. There we go. So this will help kind of trim down the guessing and checking of what you're trying to do. So angle, side, angle is when we have 2 angles that are congruent and the side in between that matches. So we need an angle. Here we see we have angle A and angle D are congruent. We have a side. So AB is congruent to DE. Let's see if I can get this to, see if that looks better. And then lastly, green, we have another angle. And the important thing for angle, side, angle is this angle needs to be between both of them on both. The main reason we have this differentiation is so you don't have 2 angles in a side with the angle between and then 2 angles in a side where they're not, where the side is not between. We have to make sure that the angle is in the same spot compared to the 2 angles. So for here, we've got angle B is congruent to angle E. Let's see if zooming in helps. All right. So we got that. Now we can state that these 2 triangles are congruent by angle, side, angle. So triangle A, B, C, and remember when we're naming these we have to make sure they match up. Some people were telling me they were having trouble with Savis being mad about the letters. I do need to make sure. So angle A matches up with angle D, angle B matches up with angle E, and angle C matches up with angle F. So there's our congruency statement. So, all right. So what this is what this can look like. So we've got 3 pieces of information. We have 2 pieces of information I can count. We know that SQ bisects RQT. RQT is that angle right there. And this is bisecting it. So we know it's cut into 2 equal parts. So how do I know that RQS, which is the top angle, is congruent to TQS, the bottom angle? I know because because QS bisects angle RQT. And then how do I know? So that's my first piece of information. Second piece of information is it tells me that this also bisects RST, which is this angle over here. So that tells me that RST's 2 halves are congruent. So we've got RSQ on the top and TSQ on the bottom. So how do I know RSQ and TSQ are the same? Because QS bisects, oh, this is painful. Here, let me try something. All right, so I've fixed that with some typing, so that looks a little bit better. So There we go. Oh, we can use this. There we go. So that's that one. And that is that one. There we go. Okay. So we have our two bisections. Now they don't give us anything else, but I do know that I need another side. So looking at my two triangles, and some people were a little confused about this in my 5th period, it sounded like. So just to reiterate, if we look at this top triangle and this bottom triangle, our QS has this side right here, QS. TQS also has a side here, QS. And we can say QS is equal to QS because they are the same thing. So we can say QS is congruent to QS because it's the reflexive property. And they call it the reflexive property in math because it's like reflecting in a mirror. So reflexive property is just saying, hey, it's the same thing, so it's equal to itself, is all it's saying. Yep. Okay. There we go. So that is our last piece of information. Oh, there we go. There we go. So we have our 3 pieces of information. We have an angle, the green pair. We have a pair of sides, the purple pair. And then we have a pair of angles over here, the purple pair. And then we have a red side in between. So I have angle, side, angle is how I know this is congruent. So there's an example of that. There's 1 or 2 more for you to try with that set. And they set you up. Later on we'll talk about recognizing which one to use and how, but right now you're just using the one you're using. So last set, or next one, angle, angle, side. So the only difference here is that we are looking at sides that are not, that do not, the side is not between the 2 angles for both of them. So we have an angle, here we have angle A and D. We have another angle. Angle E. And then last but not least, we have a side that is not between both of them. BG or BC is congruent to EF. That's gross E. Okay, so last but not least, we can make the statement. Oh, I don't think this will let me do triangles. We'll just draw it. So we can make the statement that triangle ABC here is congruent to triangle DEF. Okay, so we're going to do a couple examples. I picked those first 2. For these proofs, do not have to fill in all of the boxes. You just have to give me the 3 pieces of information I need. And then the 4th one, how you know, what does that tell me about the triangles being congruent? So I edited these already for you. I just need, on this one, I'll need 2 angles and a side, and then you're using angle, angle, side. So let's take a look at what we got. So YZ bisects, bisecting the angle cuts it in half. We got WYX here on the top, and YZ is cutting it in half, which means that these 2 angles are congruent. Next up we have round 2, the fun one, WYZ and WXZ. So these 2 are congruent as given. And that's all we got for right now. So let's type those in. Alright, so through the magic of editing, here's what we got. Draw. Someday I won't be slow at this. So we've got round one. We know these two top angles are congruent because the YZ bisect cuts them into two equal parts. We know those two angles are congruent because they were given to us as congruent. We're missing a third piece of information. I know it does need to be a side. So we know that this YZ has to be congruent to itself. So we can just do that. So YZ is congruent to itself, which is called, and I'm gonna cheat. Ooh, the reflexive property. Don't tell. Okay, so there is our third side. So now we have an angle, a non-included side. So I know by angle, side that these two triangles are congruent. So we can use that one right there. Triangle WYZ is congruent to triangle XYZ. So there we go. Just a gross S. All right, so we'll do one more just to kind of see an example. I'm going to use this one because they're using the parallel fact and that can throw some people off. So I'll get what I know to start off with and then we'll deal with this. So let's look at what we got. We have this as given. So I know that ABC is congruent to CED. These are congruent. Ooh, that's ugly. There we go. So that is congruent to that. We could also, since they're all by themselves, just say that angle B and angle E are congruent as given. Second easy one we can see is C is the midpoint of AD. So C is in the middle, just like bisectors. C is splitting AD into two equal parts, AC and CD. So there's our second piece of information. I'm going to type those in really quick. All right, so that's what we got. So we have, just as a quick touch because it's been a sec for me, ABC is congruent to CED because it is given. And I know that AC is congruent to CD because C is AD's midpoint, so it's split it in half. Now we need another piece of information. So let's look at what we got. So they tell me this, that I got some parallel lines. So let's look at our parallel lines here. We used red. So we are, there we go. So AB is parallel to CD. So I'm going to pull that out and just draw it over here. AB is parallel to CD. And then what I also see is we have some transversals. I'm going to focus on this one because it cuts through both lines. You could use this one as well, but looking at the angles, it's not going to be as helpful. So I'm going to use that right there. Actually, wait, I can do this. I'll be fancy. So we're looking at AB is parallel to CE. All right, so there's those. I'm going to pull that over here. So we have our AB is parallel to CD. We have our transversal AD, and we had our two angles here matching up. So I see that this angle and this angle form corresponding pairs here. So that can be our third angle. So that'll be our setup. Let me get that written in. All right, so BAC is congruent to ECD, and those are because they are corresponding angles. of parallel lines with a transversal, but if you tell me corresponding angles, I know what you mean. So we're not going to worry about proving all the extra stuff. We'd have to say, well, since they're parallel, they are corresponding but you can just say, hey, I know this angle is congruent to that angle because they're in corresponding angles. This is probably the parallel lines ones are probably the hardest ones to find because it's not as clear cut, but that's our last key that we need. So all right, so we've got, let's see what we got. We got an angle, we got a side, and we've got an angle. Even though I haven't written this order, we have the side is not between the angles. So we have two angles, then a side. And this is enough to show that triangle ABC is congruent to triangle CED. And we are done. So just to clarify, just give me what three things do I know are congruent. It's got to be some three things: an angle, a side of some sort, some combo of those. Tell me how you know those pairs are congruent, and then which of these we're using. This one will be pretty organized, so if you're using side, side, side on this, something went terribly wrong, but eventually we'll be moving towards that. Hope you're having a good Wednesday, and I will see you soon.